Hello, welcome to Chapter 7, homework questions 53 through 58. Question 53, solve each equation below for x. Check your solutions. So we'll go ahead and start with part A here. We have 3x minus 7 times a quantity, so we will distribute the negative 7. So we will get negative 28 minus 14x is equal to negative x plus 2. Once we use the distributive property, we can combine our like terms. On each side, negative 11x minus 28 is equal to negative x plus 2. We now want to get the variable term on one side and the constant term on the other side. So you can see me adding x and adding 28. So that'll leave us with negative 10x is equal to a positive 30 divided by negative 10, and you get x equals negative 3. It does tell us to check our solution, so that means we want to plug this back into the original to see if it is correct. And so there is the check. You just have to be careful with the negative signs that are happening when you're plugging in negative 3. So like on this second part here, you have the negative 3 for the x, but also x is opposite of negative 3, so it does become a positive 3. And on the left side, you want to make sure you simplify everything inside the parentheses. So the first thing you need to do is take the 2 times the negative 3. And then simplify this before you multiply by the negative 7. And then you add the negative 9 at the very end. So you just got to be really careful with your order of operations when you go to check part A. All right, now on to part B. Part B says we need to take negative 5x plus 2 minus x plus 1 is equal to 0. So we can combine our like terms. And then once again, we want the variable term on one side and the constant on the other. And when you divide by negative 6 here, this is negative 3 divided by negative 6. So this will be a 1/2. Make sure you're dividing by that negative 6 on that one. And you're getting the fraction 1/2, not 2. So once again, go ahead and plug 1/2 back into your equation and check it. And so once again, you can see the check here. I first took the negative 5 times 1/2. And then the second part, I just worked from left to right because I was left with addition and subtraction. So then I did this one, and then I subtracted those, and then this one, obviously. So once again, you can see the check, but you do have to be careful. Question 54. Jerry says, I've got money in a great account that compounds interest monthly. The equation is y equals 388 times 1.008 raised to the m. Represents how much money I have at the end of any month. What is Jerry's monthly interest rate? Write an equation to represent your total money if you invested $500 in an account with the same rate of return. Let m represent the number of months the money has been invested. All right, we got a couple questions here. The first one is we want to figure out what the monthly interest rate is. So our interest rate is our multiplier. So that'll be a value of 1.008. As a percent, that is 100.8%. But that's not the interest rate. The 100% is what you have originally. And then on top of that, you were able to add 0.8% to that. So the interest rate will be 0.8%. So that's the first question. The next question says, write an equation to represent your total money if you invested $500 with the same rate of return. So it'll be similar to the equation above, but your initial value is now 500. The interest rate is the same because it's the same rate of return raised to m, which is the number of months. Question 55. Solve each system of equations below. So we have two different ones we're going to look at. The first one is 2x plus y equals negative 7y, and y equals x plus 10. So if you're going to do a substitution, you want a variable solved for. And if it's already solved for, that's good, like it is in this one. If not, you can solve for a variable to get by itself. If you want to use elimination, you ideally want the x and y's on the same side lined up equal to the constants. So it looks like on this one we're going to go ahead and use substitution. So wherever there's a y, we're going to plug in x plus 10. There's two y's in the previous problem. We could have simplified that, or if we just leave it this way, we can go ahead and just replace both y's with an x plus 10. Just make sure you have to do both of them if there's two of them. So we have 2x plus x, which is 3x. So we got 3x plus 10, distribute the negative 7, that's negative 7x minus 70. And just as before, we're going to get the variables on the same side. So we have 10x plus 10 equals negative 70. Subtract 10, and that'll be negative 80. Divide by 10, and x is equal to negative 8. Now that's just the x value. We still need to find the y value, so we can plug the y value, or we can find the y value by plugging x equals 8 in for x into the second equation, and it looks like we get y equals 2. So our solution to this system is the ordered pair negative 8, comma 2. Now, if you, before I move on to the next one, if you wanted to simplify this equation on top here, because there is a y value on both sides, you could do that a couple different ways. You could either add the 7y to both sides and get 2x plus 8y equals 0, or you could subtract the y. So if you wanted to do that, you could. I didn't do that in the problem that way, but once again, it's possible. Part B, you have a 3x equals negative 5y and a 6x minus 7y equals 17. So if I'm trying to do substitution here, because all of my coefficients are some value other than 1, then most likely I'm going to get fractions if I try to solve for one of those variables. So instead of doing that, I'm going to rewrite this so that I have all my x's and y's on the same side. So I'm going to add the 5y, which means I have 0 left on the right side. And then my second equation is already set up that way, where I have my x and y lined up and my constants on the other side. And now we just have to pick which variable we want to eliminate. I would say the x would be the easier one. We can multiply the top equation by negative 2, and we get negative 6x minus 10y equals 0. If you chose to get the y's the same, they would be 35 and negative 35. So if you did it that way, it's fine too. My x's are eliminated. I get negative 17y equals 17. Divide by negative 17, and we get y equals negative 1. And now I'm going to take the first equation and plug in y equals negative 1. So we get 3x is negative 5. Plug in negative 1 for y, and then we get 3x equals 5 divided by 3, and x is equal to 5/3. So our ordered pair would be 5/3 comma negative 1. Do not write 5/3 as a decimal. You can write it as 1 2/3, that's fine, but not as a decimal because it's a repeating decimal. Question 56. Find the equation of a line with an x-intercept and a y-intercept. So you need two things for an equation of a line. You need the rate of change, and you need the y-intercept. So the b represents the y-coordinate of the y-intercept, and the m represents the rate of change, or the slope. So we're given one of those. How do we find the slope given 2 points? You can do the change of y over the change of x. And so it looks like we get negative 9 over negative 4, or 9/4. I wrote a 5 for some reason. 9/4, or 2 1/4, 2.25. And so therefore we have enough information to write the equation. Y equals 9/4 x plus our y-intercept of 9. Question 57. In problem 610, Battle Creek cereal was considering a variety of packing options for toasted oat cereal. They wished to predict the net weight of cereal based on the amount of cardboard used for the package. Below is a list of 6 current packages. Now, you are going to need a graphing calculator, or if you know how to use Desmos, you can use that as well. You got the packaging cardboard inches squared on the left, or your independent, and the net weight of the cereal grams on the right. And so in part A, it says, in the previous lesson, you may have hand-drawn a line of best fit for this data. Now I want you to use your calculator to find the equation of the least squared regression line and sketch the scatter plot. Now I can't show you how to do all of the graphing calculator stuff on the video, but remember, you have the sheet that kind of goes back through and explains that. You have to set up your scatter plot, your list, input those, and then sketch the scatter plot. So if you do that, you should get what this scatter plot looks like. I also included the least squared regression line on the scatter plot as well. So make sure you turn your stat plot on, and you also calculate your least squared regression line. So part A should look similar to what you have here. I also need the equation. So when you calculate the least squared regression line, you should get y equals 2.29x minus 132. So then in part B, it says sketch the residual plot and interpret it. So once again, on the graphing calculator, you need to create that third column for the residuals, and then you will plot the residual. Make sure you once again do zoom stat. And so this represents the residual plot. You have the packaging, which is in inches squared as your x-axis, and then the residuals in grams. That's how far the actual is away from the predicted. So that's the sketch, but also to interpret that, well, are they scattered? I mean, that's what we're looking for. Is this a good model? The data should be scattered. But it looks like we have a pattern here where it's not scattered. So therefore, the residual plot tells us that a nonlinear model might be a better model for the data. And so there's the answer to part B in terms of interpreting it. Moving on to part C, since this equation involves area, a function with an exponent of 2, and weight, a function with an exponent of 3, try fitting a power model to your data. Recall that a power model has an exponent in it and has the form y equals a x raised to the b. So make a residual plot and interpret it. So once again, you can see on the screen here, I've already created the new regression using the power model. And you can see that the data definitely seems to fit the points a little bit better. And then the residual plot is over next to it. And you can see now, look at the residual plot. Do the points seem to be more scattered? So we would say on this one that, yeah, it does seem like the residual plot, the points are more scattered on this one. So the power model would be a good model. And so there you can see the answer to C. And then on part D, it says, what is the equation of the model that fits your data best? Once again, this is what you would be pulling from your calculator when you calculated the regression line with the power model. So we would get y equals, your initial value would have been 0.118, and then x raised to 1.467. And so that finishes up the question 57. Question 58. Determine which of the following equations are true for all values. For those that are not, decide whether they are true for certain values or not true for any values, and then justify your decision clearly. So is it always true, sometimes true, or never true? So in part A, you have x minus 5 squared. Is that equal to x squared plus 25? Well, remember, with a binomial, if it is being squared, you want to make sure that you expand it out and then use your generic rectangles to figure out what the value or the area is. Now, we can also use the distributive property to do this as well. So x squared minus 5x plus 25. Is that equivalent to x squared plus 25? And you'll notice that you have a middle term. It's negative 5x minus 5x. So are these two equal to each other? Is x squared minus 10x plus 25 equal to x squared plus 25? And what we can do is we can solve this. Obviously, they don't look equivalent here, so we'll subtract the x squareds. That'll leave us with negative 10x plus 25 is equal to 25. Subtract 25 from both sides and get negative 10x equals 0, and then divide by negative 10. So they're not equivalent in most cases, but there is actually one case where it is equal to, and that's when x is equal to 0. But in all other cases, this would not be a true statement. So this would be considered sometimes true, but only when x is equal to 0. Okay, and so that's what we're looking for on these questions. Let's go to question B. We have 2x minus 1 times x plus 4 is equivalent to 2x squared plus 7x minus 4. So this one's similar to the one we just did, but now you have a binomial times a binomial already expanded out. This will give you 2x squared plus 8x minus x minus 4. And as I said, you can use the generic rectangle or the distributive property. Combine your like terms, and you get 2x squared plus 7x minus 4 and 2x squared plus 7x minus 4. Now, if you're thinking about this, these look and are exactly the same. So we could stop here and write our answer if you can see what the answer is. If not, I'm going to go ahead and continue. If I subtract my 2x squareds, they cancel. If I subtract my 7x's, they cancel. And we're left with negative 4 equals 4. You can even add the 4's to both sides if you want. Either way, you're going to get 0 equals 0, which is always, always, always true. So all values of x will work in this case. So our answer to this one is always true. And we've justified that by solving. All right, on to part C. We have 2x squared y cubed over y squared is equal to 2x squared over y, or 2x squared y. So we need to simplify the left side, and I'm going to do this because I think it's easier to see a lot of times by expanding these out and then seeing if we get what the right side is. So by doing that, we can see that y divided by y is 1, y divided by y is 1, and so we get 2x times y is equal to 2x squared y, or 2x squared y is equal to 2x squared y. So at first glance, because you have 2x squared y is equal to 2x squared y, we're probably thinking that this is always going to be true. But one thing is we want to make sure it's true for the original problem. And even though all those values would work down here, if you look at the very original problem, we were dividing by a y squared. So we can't divide by numbers, we can divide by every number except for 0. So is there a number that we can square that gives us 0? And that number would be 0. So that means y cannot equal 0 because we'd have to divide by it. So this would, it's a little tricky though, this would actually be sometimes true, and it's true for all x and y values except y equals 0. And so there you go. So that one you just got to be a little careful with, especially with the original having division. And then on D, once again, this looks similar to the ones we've done on A and B. 3x minus 2, 2x plus 1 is equal to 6x squared minus x minus 5. So we'll work this one out the same way. 6x squared plus 3x minus 4x minus 2. Combine our like terms. 6x squared minus x minus 2. And so it does look a little different here, so let's go ahead and keep solving. You might see, once again, what's happening. So this would be negative x minus 2 is equal to negative x minus 5. We'll add the x's to both sides. They cancel out. And we're left with negative 2 equals negative 5. So this is not a true statement, never will be a true statement. So this one would be never true.